No, I think we don't say until we'll have it in person.
Okay, so yesterday we took the test, just the results. With the test corrections, Delta Math made a little change where the test corrections are automatically linked to the test, which makes perfect sense to me. And so now you don't have to set up the corrections; they're just in your already in Delta Math as an assignment for you. So make sure you get those done by Monday. Any questions on that? Okay, moving on. So the next unit we're going to talk about is area, which is something you've definitely talked about before in mathematical career. So today we're just going to talk about areas of triangles and parallelograms. So first of all, remember a couple basic shapes here. If you have a rectangle, this, and this is base height, then the area equals base times height. Should definitely be familiar to you. And a special case of this is if you have a square. A square is just a rectangle in which all the sides are the same length. Then the area equals s squared. The length of the side squared. Okay? So those are things you should definitely remember from a long time ago. So let's talk about parallelograms first. So parallelogram compares the parallel sides. The formula is area equals base times height as well. But this formula, in this formula, the base is just the length of base, but the height is the perpendicular measured height. It's not the length of one of the sides, it's the perpendicularly measured height from the top to the bottom. So the height, this measured perpendicularly. Okay, and it makes sense, it should make sense that this is the formula because why this is true. If you take a parallelogram, you could think of, you could like chop off this corner here and take this triangle and just glue it on over here. Right? If you took that little triangle and chopped it off the corner, glued it on over here, you just have a rectangle, right? And hopefully it makes sense that this rectangle's area is B times H. Right? So that's really why the formula for area of a parallelogram is base times height, because you can turn a parallelogram into a rectangle super easily by just taking one of those corners, chopping it off, and putting it on the other side. So that's why the formula is base times height. So these problems are super easy. They're going to give you the base and the height, and you have to calculate the area just by multiplying them. So if you have something like this, and they told you this was 8 feet, and perpendicular height is 5 feet, then the area would be 8 times 5, 40. And the units, when you're talking about area, are always square units. So this is going to be feet squared, square feet. Okay? So let's remember always use units squared for area. So it's going to be square feet, square inches, square centimeters, square miles, whatever. What?
Square. Square. Everything.
Units, yeah. Okay, now, one way that they might try and confuse you is they might give you more information than you actually need. Like, for example, they might give you a parallelogram, this. I always find it hard to draw a parallelogram backwards for some reason. It's hard to make it look right. And they might give you, for example, they might say this is 10 centimeters, and this is 7 centimeters, and this over here is 6 centimeters. But you won't be fooled by this, okay? But if this was multiple choice, I guarantee you 70 would be one of the choices, because people would accidentally multiply the length of the side of the parallelogram instead of the height of the parallelogram measured perpendicularly. So don't fall for that. The area here would just be 10 times 6, or 60 centimeters squared. Okay. Another thing that they might do sometimes is they might give you a parallelogram where the perpendicular height isn't in the interior of the parallelogram. Like, for example, they might give you something like this, a parallelogram that's drawn like this. Okay. In this case, if this base right here is like 4 inches, okay, they would have to extend the base out and then measure down to that extension perpendicularly. They have to keep that height there. Okay, so if this distance was like 5 or something like that, inches, then the area would be 4 times 5, 20 square inches. Pretty easy though, right? Nothing here is too tricky. Just be careful of this situation where they give you too much information. You got to know which information is relevant and which isn't. Okay? So that's area of a parallelogram. The next thing then is area of a triangle. Triangles. If I have a triangle, looks like this, for example, the area is 1/2 base times height. And again, the height is measured perpendicularly. This would be the base here. And the height would be perpendicular height or altitude, h. Not the length of one of the sides necessarily. The only special case in which the height is actually going to be a length of a side is if it happens to be a right triangle that's sitting on one of its legs. Okay? So again, this is logical that this is the formula. If you just think of it this way. If you have a triangle that looks like this, you can always take a triangle that looks exactly like it and just glue it on next to it, like this. If you took a triangle that's congruent to this triangle and just flipped it around and glued it on over there, what shape do you end up with? No, a parallelogram. It's only going to be a rectangle if this is a right angle, which is not. So it's a parallelogram, and we know the formula for a parallelogram is base times height. This is b, and this distance right here, measured perpendicularly, is h. So if the area of that whole parallelogram is base times height, this is exactly half of it, right? So this is 1/2 base times height. So the area of the parallelogram is base times height. So area of the triangle is 1/2 base times height. Again, if stuff makes sense and it's logical, it's a lot easier to remember. Okay? So same issues here. If they're going to give you base and the height, just make sure it's the perpendicular height. So if it was something like this, they might give you this distance here is 6 yards. And this distance here is 11 yards, measured perpendicularly. So then the area would be 1/2 6 times 11. Half of 66 is 33 square yards. Sometimes they'll mix it up by giving you a triangle that's situated on its hypotenuse. Say this is the right triangle. And they might say this is a 5, 12, 13 triangle, Pythagorean triple. What's the area? Really? No one? Yeah, how'd you get that?
To half of 12 and multiplied by 5.
Yeah, okay, so you can't think of 13 as being the base because we don't have the perpendicular height measured to that base. You got to think of it like sideways, either this as its base, the 5 segment, or this as its base, the 12 segment, right? So the area in this case is 1/2, 5 times 12. Half of 60 is 30 square units, whatever they are. I didn't give units, but square units, whatever they are. Okay, so be careful about situations like that. And same thing goes for, they might give you an obtuse triangle, something like this, just like with the parallelograms. You have to remember that the height has to be measured perpendicularly down to the extension of the base. Okay, so if this is like something like 3.5 5 centimeters. And maybe they give you this height right here is 4 centimeters. So the area would be 1/2 base times height, 1/2 of 3.5 times 4. You can use your calculator for this if you need to, but this isn't too hard. So 2 times 3.5 would be 7. So 4 times 3.5 would be 14. Half of that would be 7 centimeters squared. Okay? Any questions? Okay, so there's actually 2 assignments tonight. There's a Delta Math assignment, and there's also an IXL assignment. Don't forget, to get the IXL assignment, the best way to do it is just go to the tab on IXL that says recommended by my teacher. That's the best way to get that. But the Delta Math assignment is just called area of a triangle, and the IXL assignment is called area of parallelograms and triangles, okay? And remember, for Delta Math, you just have to get a 90. Yeah. I can't hear you. That was your question. Yeah, a 90 is 100. But an 89 is an 89. Okay, so I'm not going to be like, oh, 89, that rounds to 90, which is 100. No, an 89 is going to be an 89 if you don't get it up to a 90. Okay?
You said it was areas of parallelograms and triangles.
Yeah.